Okay. So, the first thing I want to ask you is, what is the only, we've been dealing with a lot of prefixes, right? Meth, eth, prop, but, pent, whatever. But what's the only suffix that we've really used so far? Ane. So cyclopentane, right? Or pentane, hexane, that kind of thing. The reason why we've been using ane is because the class of compounds that we've been dealing with so far has been called alkanes. But we're going to switch that up. We're going to start calling some things alkenes and also alkynes. And they represent a different class of molecules. The notes packages are at the back in the blue bin. So alkenes are hydrocarbons that have one or more double bonds in them. Now let's think about this. I want to turn a molecule into something having a double bond. So I'm going to draw just about the easiest organic compound I can. What the hell is this? C2H6. What is the name of C2H6? Is this a cyclic structure? Does it have a ring in it? Do you see a ring anywhere? No, I don't see a ring of structure. So it's not cyclo something. Okay. All right. Is it? Ethane. Yeah. It's just ethane, right? It's a 2-carbon parent chain, and you cannot have a branch on a 2-carbon parent chain, right? So this is just ethane. Now what I want to do is I want to turn ethane into ethene. And I want to ask you, how many hydrogens am I allowed to keep when I turn into ethene? 2. On each carbon, right? I'm only allowed 2 hydrogens. So when I went from a single bond to a double bond, what did I lose? Ane. Yeah. Okay, I lost the ane and turned it into an ene. But what did I lose from here to here? 2 hydrogens. For every double bond that's present, you have lost 2 hydrogens from what you used to have. Is that similar to something that we saw yesterday? Yeah. Cyclo Alkenes also represent 2 hydrogens being lost. And so now we've got more than one thing fitting this formula. So both cyclic compounds and alkenes follow the formula CnH2n. We will look at some conclusions about that a little bit later on, but just kind of more on this. So alkynes, I should have bolded that. Can you at least like underline it or something? Alkynes.
Yes.
Alkynes are hydrocarbons that have one or more triple bond in them. So if I wanted to turn this into a triple bond, what would I have to lose? 2 more hydrogens, right? So that's why it follows the rule CnH2n minus 2. So basically, the rule of thumb is that for every extra carbon-carbon bond you have, you've lost 2 hydrogens. For every extra carbon-carbon bond, you've lost 2 hydrogens. Naming is similar to alkanes. It's the exact same thing, except instead of adding up all the branches and seeing what adds up to the lowest number, all we do is we start at the end that's closest to the multiple bond. The multiple bond has a higher priority than the branches do. So, because we had a decision, we could either talk about based on branches, or we could talk about it based on double bonds, and we're just choosing to use double bonds as the higher priority. If the multiple bond is smack dab in the middle of the chemical, then you can use branches. If numbering is a tie, then alphabetical chain gets the lower number, right? It's the exact same thing as before. So let's take a look at this. What is the longest parent chain that includes the double bond? How many carbons? 5. So what is this going to end in?
10.
Pent something ene. Now, the reason why it's pent something ene, why would I ever put a dash between a letter and a number?
Of the double bond.
You got to put the location of the double bond. Is this the only place that double bond could have went?
No.
No, it could have been here, or here, or here, or here. Does that make sense? So what I want to know is we got to start numbering so that the double bond is closest to the lower numbers, right? We're going to start numbering on the side that's closest to the double bond. So where do you want to start numbering? On the left or on the right? On the left. So this is number 1, 2, 3, 4, 5. Let's all just kind of agree. Do we want to call this pent 2-ene? Because that's where the double bond starts, or do we want to call this pent 3-ene because that's where the double bond ends? We got to get this. What? Yeah, what's the more logical 2 where it starts? So this is pent 2-ene. So this is just describing the parent chain so far. We haven't touched anything related to the branches, but I mean, what's the only branch that's on here? A 4-methyl group, right? So we're going to say 4-methyl pent 2-ene. No spaces, right? All one word. No spaces. So far, all of our organic names, none of them have had spaces in them. They've all been one giant word. Yeah.
Okay, so now, when we're just naming like regularly without any double bonds, we normally start, like we want the smallest number, right?
Yep.
So how come it's different, and how come we're not naming it from right to left this time?
Because we have to make a decision. Do you want this to be the lowest number, so the branch? Or do you want this to be the lowest number, the double bond? We just have to make a decision. The community of chemists in the entire world, we just all have to get together and we have to agree on a rule where we can all follow that rule.
Okay.
And we've all agreed that the multiple bond, the double or triple bond, takes a higher priority than the branches.
Okay.
So that's just the rule that we're taking.
All right.
So is this kind of okay? Yeah? So if I gave you a name, could you draw it?
Maybe.
Yes.
Do you have a little bit of room under this?
Over here.
Over on the side? Okay, well let's name them first and let's see how much room we have, and then we'll start drawing some pictures. Yeah, so let's just do this first. Okay, so remember, we need the longest parent chain that includes the double or triple bond. So what's the longest parent chain? 4. So it's going to be butene, right? And where is the double bond? It starts at carbon number 1, but1ene. Because I'm going to draw something, but is there a difference between this compound and that compound? Assume that the hydrogens are actually there. Yeah, that's but1ene. What's this? but2ene. So there's a big difference between those two things. Oh, damn it. I didn't even look at it. Poor guy. Yeah, what's the name of this thing?
Butene.
Butene. Ugh.
No.
We're gonna have to talk about this. Why are we gonna have to talk about this? Because it's weird.
Line. That would be Butene. Wait, no.
Okay. So let's look at the longest parent chain that includes the double or triple bond. Is it everything on the bottom? Are we okay with that?
Yes.
Yeah, so this is our parent chain. So how many carbons are in that parent chain?
4.
I see 4. Do you see 4? At the beginning and end of every single line, right? So this is going to be bute, and it's going to be 1, 2, 3, 4. So bute-1-ene. Yeah. So just 3-methyl bute-1-ene. Is this okay? I'm feeling some exasperation in the crowd right now. Exasperation. A sense of overwhelming futility. You are tired of this. You don't want to do it anymore.
That is correct.
Okay.
Is there written
A
difference?
sense of impending doom. Okay. I want you to draw something for me, and you can either do condensed structural or a line diagram. That's totally fine. But I want you to draw for me. I want you to draw me.
Wait, I'm confused.
All right. So can we draw a line for this?
You can draw a line diagram. Yeah.
Okay, perfect. Yeah, draw a line.
How would you name like a cyclic double bond thing?
So the double bond has to start at number 1, and we'll talk about that
Okay.
in a little bit.
Okay.
But the first 2 carbons, carbon 1 and 2, are at the start and end of the double bond.
Oh, okay.
You have to go across that double bond, and then you just keep going whatever direction.
Okay.
Got it one time.
Got it? Yep. Lovely.
Oh, I made it too many.
No, propane.
Yep.
So that means it'd be like
No.
2, 3, 4.
1, 2, 3, 9.
That's what I got.
Perfect.
Bro, my line
Word on draw. Did you guys got?
Yes, possible.
I would warn. Why did you start it that?
Why'd you start that?
Because I wanted that.
Why'd you put yours underneath?
When you go right to left like Arabic.
Four, right?
oh, it is junior.
Oh, yeah.
I've been all.
Right to left, yeah.
Yours is so good.
Because they're just like thinner, but I really think that's
Wrong tire.
That's
the present, brother. Yeah, which one do you like better?
No, I drew mine right to left. Mine's
Which one do you like better?
it's too small.
Are you kidding me? Die. Die.
Can I have one piece now?
No, we can just.
See, that's good. I won. I love orange juice so much. It's so good. Like, honestly, like, it's cold orange juice.
I just.
Salt is kind of gross. But I just like, although I do kind of like football.
It wasn't fun.
No, it's you. It was like Alice.
Okay, I'm sorry I didn't get to everybody, but I'm gonna show you both the line diagram and then kind of the condensed diagram.
That's so cute.
So how many people decided to do a line diagram for this? Good, okay. It's easier, right?
Yes.
Like, it's lazier, I guess we should say, but that's fine. So oct to een. So oct, how would I start it off?
8.
1, 2, 3, 4, 5, 6, 7, 8. And the double bond, where does it start? On carbon number 2. And then where are my groups?
3 and 4.
So 3 and 4 are methyl groups.
And then 5 is.
And then 5 is a propyl group. Right?
That is.
Good.
You see that? He drew just like.
So I'm fine with that.
We started the other way.
As a condensed diagram, 1, 2, 3, 4, 5, 6, 7, 8. And the double bonds in between 2 and 3. And then we need a methyl here, a methyl here, and a propyl. And then I would just fill in all the hydrogens, right?
Yes.
How many hydrogens can go on this first carbon? Shh. How many hydrogens can go on this first carbon? 3. So CH3. How many hydrogens can go on that one?
2.
How many bonds does it have? 3. So 1 more, right? How many can go on there? How many does it have right now surrounded? It has 4, right? I see 1, 2, 3, 4 bonds going into this carbon. It's not allowed any hydrogens. Is that okay?
Oh.
So this one has 1. This one has 1, 2, 2, 3. Good. Hopefully that makes sense. Hopefully that's okay. So these are triple bonds. They're the exact same thing as enes, except we call them hynes. Go ahead and try and name them for me. What?
Is it like?
You made it here.
1020 was
Right.
it was
Sorry, I couldn't.
It was something.
You did it wrong.
Because you have to
Literally
start
just.
Oh,
You did no difference in the double bond.
It's 4 methyl. You know what
Are you okay? Go to bed.
Because you took it out of my hand. And you tell me as a race.
Love math.
He has like a scrape, so he'll just be like this and like a potato Why don't you just cross the points?
So far away, it's a lost cause.
It's a lot.
I got chemistry to be doing.
Any questions? Okay. So, which way do you want to start numbering it? Again, what takes a higher priority? The multiple bond, the beginning of the multiple bond, or the branch?
Beginning of the multiple.
The beginning of the multiple bond. So if I number it this way, 1, 2, 3, 4, 5, what's the number on the multiple bond going to be? It's going to be a 3, right? Is this anybody's pencil?
Yeah.
All right. But if we name it the other way, 1, 2, it starts with a 2. Would you rather the multiple bond start with a 2 or a 3?
2.
A 2. So this is going to be, it's going to end in pent 2 ine. And where's the branch?
4 methyl.
On 4. So 4 methyl pent 2 ine. Good. What's the only difference between the top one and the middle one? Yeah, this is 4 methyl pent 1 ine. Good. And then the bottom one, do you want to start numbering from left to right or right to left?
Left to right.
Left to right. So this is going to end in butte, 1 ine, and then it's going to be, where are the methyl groups?
3 dimethyl.
So it's going to be 3, comma 3. You have to tell me where both of them are. Yeah, you have to put 3, comma 3 dimethyl.
Dimethylbutane.
Dimethyl but 1 ine.
Dimethyl.
Good?
Dimethyl.
Good? Go ahead and draw these for me, please. What? No, it could be line diagram. Actually, you know what? Draw these using line diagrams. I'm forcing you to draw using a line diagram. Remember, you always start 1, 2, 3, 4, 5, 6. Right? Non is an I.
Oh. How?
Yeah. No, it's that. No. You're good.
That?
You're good.
Yeah. So do it the other way.
Wait, propane.
Look at me, I'm drawing straight lines now. Should be a pro.
What's that?
It's good to check. I didn't tell you, did I?
You said
Yeah. Let's call this 2, comma. Nope. Never mind. You try and figure it out. On that very last one, try and figure out where they have to go. There's only one way of drawing that last one.
Pencil is
that's not. I guess.
2.
Oh,
Nope.
yeah.
Because look at that card that you just drew down.
Yeah.
Yeah. Look at your second card. How many bonds does it have?
Oh. I see.
That's, okay. First of all, how many carbons are in your parent chain that you drew? Count your carbons. Yeah, okay, good. So we can only can't put them on the last one because that would extend the chain. Yes. I know, I understand that. So draw the parent chain and figure out where they have to go.
Wow. Does it matter where I put the line, like whether it's on
No, it doesn't.
top? Doesn't?
If it's a triple bond, I put one on top and one on the bottom.
Okay.
You're gonna have a normal bond, put one on top and one on the bottom.
Okay.
Now, that's not wrong if you go bond and then bond.
Why do you avoid
It just, it's gonna look weird to me, but that's fine.
triple bond? Why do you take three?
Okay, so there is one mistake in one of these names. Could anybody find the mistake that's in one of these names?
Is it in the last one?
No.
Oh,
Natasha.
Dash between propyl and
Yeah, that shouldn't be there. Should be propyl non-3-ine. But
How would that work?
okay, so let's look at this. Hept-2-ene. What the hell is hept? 7. 1, 2, 3, 4, 5, 6, 7. And the double bond is on the 2 to 3. There's a 3-ethyl, so 1, 2. There's a 2,5 dimethyl, so on the 2, 1, 2, 3, 4, 5. And that looks like it's good. So try and make sure that yours looks kind of like mine. Okay. Non-3-ine. I'm going to show you how most people would draw a triple bond. And you're probably going to see it like this, and I need you to be aware. It's not wrong the way you're doing it, okay? But non-3-ine. So how many carbons in non? 9. Okay. So see, how am I going to do this? So 1, 2, 3. But then after the third carbon, there's a triple bond. Often there's no angle because triple bonds, in reality, they make a totally linear compound. So these 3 bonds are all totally in a line, in reality, okay? Now, I'm fine with it if you drew it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and you just went like this. I'm perfectly happy with that. Please don't think that I'm being overly critical, but I just want you to be aware that you are often, if you see a triple bond, you will often see it being represented like this, and you have to know that that's 1 carbon, that's 1 carbon, that's 1 carbon, even though there's no apexes or vertices. Is that okay? Yeah, you don't like it, but you have to understand it. You just have to be aware that that's a possibility. So if you want to draw it like this, I'm perfectly happy with that. That's no problem. 2,6 dimethyl, so 1 here, 3, 4, 5, 6, 1 there. 5 propyl, so 1, 2, 3, 4, 5. 5 propyl non-3-ine. Good. And then I didn't have to put the numbers here. I could have, but dimethyl but-1-ine. So 1, 2, 3, 4. And the but is right here. Hello, this is Graham. That's okay. That's fine. Yeah, that's fine. Okay, fine. Macy, can you just go to the bookstore, please? Okay. So this is but-1-ine. Now let's see. I want to put 2 methyl groups on here, but the methyl groups can't change the name. So can I put a methyl group on the first carbon? No, you're not allowed to put branches on the first or last carbon, right? Because that extends the parent chain. So I can't put the methyl group on the first or last carbon. So what are my only 2 options? 2 and 3. Now let's look at 2. Can I put a branch on 2? No. Why? It's already got 4 bonds. Do you see this carbon? I see 1, 2, 3 going into it, and a 4th one going into it. So can I put a branch on here? No. So the only place I can put my 2 methyl groups is on the 3rd carbon. Now, you could totally see it being represented as 3,3-dimethyl butene. That's totally fine. I got no problem with that. But I just wanted you to think about that. I forgot that I put that in there. Okay. So far, have alkenes and alkynes been way more complicated than alkanes? No. It's one extra rule. Just the triple bond. Yeah, actually, I find it easier as well because I don't have to add up the branches. You just go to the side that's closest to the triple bond, right, or the closest to the double bond, and then you just start going. I am going to give you. This is going to be a little tiny bit more complicated.
I think we should just wait.
Cyclo Alkenes and Cyclo Alkynes. Okay, but no, if I did this. If you had this compound, okay, and I had a methyl group there, when I look at this, when I look at my ring, I look at my ring structure. One of these two carbons has to be number 1, and the other one has to be number 2. Does that make sense? We have to start at the double or triple bonds. Because there's no beginning or end, remember how yesterday we were starting at the branch? But remember, branches no longer have highest priority. It's the double or triple bonds. So because we have to start at the double bond, do you want to start here and go that way?
No.
Or do you want to start here and start numbering that way? That way? Okay, so let's try this. This is going to be carbon number 1. This is going to be carbon number 2, 3, 4, 5. 6. So where's the methyl group?
5.
It's on the 5th carbon, right?
That can't happen.
Well, it's not that it can't happen. It's just that that's kind of interesting. That's all. What if we were to do it the other way? So start at 1, 2, 3. Does that make more sense?
Yep.
I think so. Okay, let's actually go over it and let's look at the rules. Alkenes and alkynes can still form cyclic compounds. They are named as Cyclo Alkenes, right? So always be number 1 and number 2. Look at this. Cyclobutene. Why did I not tell you where the double bond is? Because it's always 1 and 2. So let's draw 3-methylcyclobutene. So how many carbons are in this cyclic ring here? 4. 1, 2, 3, 4. And where do you want the double bond to go? Top, bottom, left, right?
Bottom right.
Bottom, sure, bottom.
So it doesn't matter where you put it?
Doesn't matter where you put it. God. Okay, so what do you want to do? Do you want to start numbering the bottom left carbon as 1 and go across the double bond to 2? Or do you want to start numbering the bottom right carbon as number 1 and go across the bond to 2? These always have to be 1, 2 or 1, 2. Which one do you want to do? 1, 2. 1, 2. Okay, 1, 2, 3, 4. So where's the methyl group?
3. Wow.
I could go the other way, and if I went the other way, I'm going to group these together. And if I went the other way, it would just be there, right? It's okay, calm down. It's fine. There's still C's. But instead of being over here, it's over there, right? But that's just...
You really got an armpit pocket.
Whatever. Okay, let's finish this off. Shh. Let's finish this off. How many hydrogens are we allowed to have on carbon number 1? 2. 1. Double bond. How many bonds are going into carbon number 1? 3. So we're only allowed 1 hydrogen. Same thing with 2. Same thing with 3. 4 needs 2. Good. Okay, I want you to try these, please. Remember, you don't actually have to tell me where the double bond goes because we assume that the double bond starts at which carbon? 1. We assume it starts at 1, so you don't have to tell me, right? This class is epic. I can't tell if that's sarcasm or not. Yeah. Yes. Well, no.
It's literally just behind you.
You're missing something.
Cyclo Alkenes.
Okay, tell me the name of that thing again. No. Well, okay, you have it, but he doesn't.
Does it start with Cyclo? No.
Yeah, it's Cyclo. If it's like.
Yeah, if it's just like.
What?
Am I writing so I didn't do those questions.
Yeah, I know you're dead.
It's like, just like what's the
Were we supposed to do the front page?
Or is it? Oh no, I guess that's it.
Wait a second. Wait a second.
Die. So essentially, look, it gives you the name right here. Yeah. This is probably, you probably have to. Yeah. Oh, you have to draw this. This is different from this. You have to name this and then you have to draw this one.
That's fine. At the end that I can't count. I just want to break the up.
You don't need any variations.
And it would be
1, 2, 3, 4, 5, 6.
What's the? Is the
1, 2, 3, 4, 5, 6.
Is it decascope? Yeah, it would be 1, 2, 3, 4, 4, 5, 5, 6, 7. Deca. No. Yeah. Deca methyl.
I'd like you to show me the where to draw this.
The last one?
Your line.
Yeah, I know. It can't be, right?
Yeah.
So, and that's something that in university or in college or something like that, you'll learn a little bit more about how the more strain, like if I took this chemical and I started to bend it, and I started to twist it out of the shape, do you think that's making it more stable or more unstable? Unstable, right? It wants to snap back into shape, right? So if that molecule, if it wants to be in a long right?
What if there's an understanding?
It's like this bond and the bonds coming on, and they're all in one bond, right? But if you're bending that bond, those bonds, that's super. It wants to.
Micro.
I know what I'm doing. I like this.
Okay. Okay, for the first one, how many carbons in this parent ring? 6. So it's cyclohexene, and I don't have to tell you where the ene is, right? Because we assume it to be at number 1. Are there any branches? No, we're done. That's it. Cyclohexene, right? This one, how many carbons in the parent ring?
6.
So it's still cyclohexene, but do you want to start numbering it 1, 2, 3?
Yes. Yes.
Or
No. Stop
do you want to start numbering it 1, 2, 3,
No.
4, 5, 6?
No.
No. So 1, 2, 3, right?
Yes.
3 methyl cyclohexene. Okay, the last picture, turning it into a name. This is a cyclo what? Cyclopentene. Good. And how many methyl groups do we have? So we're going to say 2, 3 dimethyl cyclopentene. All one word, right? And then the very last one. Cyclopropyne. How many carbons in this ring?
3.
1, 2, 3. So 3 carbons. There has to be a triple bond somewhere. Do you want it to be on the left, right, or bottom? Bottom, sure. Now, a lot of people have noticed normally those triple bonds are supposed to be totally straight, right? From the the bond going in, the triple bond and the bond going out is supposed to be totally straight. Is that possible here? No. And this is something that I was saying. The more you'll learn this in your university organic chemistry if you take it, and that's the more you put strain on a molecule. If this molecule wants to be this shape, the more I bend it out of position, do you think that's making it more stable or more unstable? Unstable. This is a higher potential energy than it was before. So if you have this compound, this methyl cyclopropyne, this is an extremely unstable high energy molecule. So if you give it a little bit of energy, it will absolutely break apart and release some energy. Okay, so that's just the idea. Let's think about this. We're going to talk about isomers, and like I said earlier, let's compare this to a normal alkane. Let's compare this to a normal alkane. If this was a normal alkane, it would be C5H12, right? It would be C5H12.
But it lost 2.
H12. What are all the ways that we can lose 2 hydrogens? A cyclo or a double bond, a single double bond. If I had 2 double bonds somewhere, I would lose 2 times 2, so 4 hydrogens. Does that make sense? So there are 10 possible isomers of C5H10. Either have a ring in there or have a double bond somewhere. And so there are 10 possible isomers. Remember, there were only 3 isomers of C5H12, right? So if you get 1 to 2, that's not good enough. Boo.
Why is
I
it
will
if we
boo
use
you.
that 1%?
Right? If you get 3 to 4, that's not bad. That means, okay, you can see some of them, sure, no problem. If you get 5, that's fantastic. If you get 6, that's awesome. If you get 7, that's super ridiculous. I have all 10 written down, drawn under this thing. So I'm going to give you 4 minutes. Is that okay? I'm gonna give you 4 minutes.
5, make it 5.
No, 4.
Make it 5.
No, 3.
4.5.
3.
4.5.
3 now. 4 because you're a terrible
Gosh,
negotiator.
shut up.
I know me. Yeah. Make sure that your isomer has only 10 carbon or hydrogens.
So chalky. Ready?
Yeah, you could. Okay, so if you moved it from
Because it's just like
So we want 10.
Yeah, I was there.
The other build was you get rid of this. So that means you can add in a double bond here.
now what I want
Which will automatically bring your 1. Actually, we can add in a triple bond here. To make it 0. Then these two can't bond. 3. Just sabotage myself. 3. Oh no, wait. Yeah, never mind. Just make it another bond. Yeah. Now. Yeah, there we go. Heck yeah.
Need 6 more.
What else you got, man? 1, 2, 3.
because you lose 2 hydrogens.
Yeah, that's both.
As long as it has 10.
This is already 9.
That's what our isomer is.
Straight?
Doesn't have to be 5.
5, yeah. 1, 2, 3, 5. This is also 5. 1, 2, 3, 5. This one has to go over here.
Well, that's what I'm saying.
as long as it's not a perfect, it's just a hydrogen, but it's
It says as long as it has 5 carbons in it. There's still 5 hydrogens.
So this would have 3, this would have 3, this would have 9 already. So we have to put a double on it. No?
Wait.
This would have 0.
well, there's but you lose two.
Actually, no, this right here is a 1.
Either apart because
You can't have different carbons in total. You could have instead of a 5,
So 3, 3, 2, 6,
4, but then you have to
I need to cut this 2 down
a
to
single. No. Yeah, that's fine. So you need C5. That's what the term isomer means. You need
This also this one right here already has 1.
I don't know if these are isomers.
This one right here already has 1. So 9.
Yes, that's perfectly fine.
Because
that
if
matters.
this one right here still has an extra 1.
exactly. So that'd be what?
So if we place one right here, 3, 3, and then this goes down to 2, and 1, 2, 1. Also gives us 3. There, that right there is an isomer.
Does that count? Yeah, and that. And one more, and then I'm set.
Okay, so
Okay.
So.
Oh, I
So
see
you,
that.
okay, so you have, you have 4,
Yeah.
5 carbons all at once. You can't really change. Well, you could. Instead of, how else would you arrange 5 carbons?
It is.
Can you please see if it's the right? Because I don't know. I'll just draw the lines. But I have
You have to have either, because we've lost 2 hydrogens, right? Compared to the normal alkane, you can either have a ring or you have a what? Not both, right?
yeah.
You can't use a triple bond. Why? Because when I make a triple bond,
never mind that one.
each extra bond, so that's 2 extra bonds, each extra bond takes up 2 hydrogens, right? So this, if it was C5H8, you could, but we've only lost 2 hydrogens, right?
Are any of these right?
Double bond.
If I just move the double bond around a few times.
You
Yeah,
either,
that's
because is this the same as the regular alkyne?
Oh wait, never mind. So that means that.
3.
You already got 9, right? So that means either we have
3 hydrogen, 3 hydrogen, 3 hydrogen, and then you got 1 over here, which is going to be taken by this.
Yes.
But you didn't count for this. This one still has 2. 1.
Not alternate.
Let's go again. Yeah. Then we'll do it.
there. So that works. Well, here,
So I don't know if any of them are.
it doesn't matter. These are all
Make it help, then we can at least be no bad.
If we named this,
Okay.
it would be
And then if we figure out one more, we can be X.
Why
Why is there not a
But are
category?
these RPK match or the other
Bro,
ones?
I want it to be gone.
used the shotgun? Have you used the shotgun?
where else?
That's sweaty.
You should.
That's sweaty here.
They're probably all wrong.
Yeah, that's crazy.
I have 4.
Okay, this one.
He kind of gave it to me though.
This one's.
I had 6.
And it's like, this is 2.
Yes, yes, okay.
Yeah.
This is the same thing.
Okay, go ahead. 1, 2, 1, 2, 3, 4, 5, 6, 7, only 8 hydrogens. I mean, we just go from.
Yeah, no, yeah, no, yeah.
I can do it. I don't like it because it's very tiny.
Honestly, like, you know,
So this is two methyl. This is two methyl. Yeah.
And I'm just trying to find my fourth one. It's only up to
You know what? In there.
Okay, why is two?
yeah. But it's
Exactly.
Wait, what is this?
That's what I tried to do, but then I go.
Because they have different names, right? If you name them, I swear you just the same. Yeah.
That was bad funny.
I'm just trying to.
So you can put the double on.
So my friend.
You were sleep talking.
Now, a double bond is.
Can you have a double bond?
So what about drawing?
Just says my name for 5 minutes and it looks like a play. Wake up, wake up.
Who is that?
It's not even with her. It's my friend Chloe. She's a dog.
One lap. No, it's not though. I just do it because she does it. It's good for you. You understand why we're doing I get it. Okay, so instead of having a 5 carbon, what I have? That one? It is. I'm just not gonna be.
Sisters or your girlfriend's a psychopath.
no, like, I swear to God, she's like,
No.
I know. She's like,
A ring does.
Apparently, I think she downloaded
Oh,
the
well, yeah,
Tried to like
Does that make sense?
Is that like silver?
I don't know, it's like a weird app, like it detects noise.
So you got 14 more carbons that you got to put on there.
Because I was like, how'd you get all those? Which one's it?
I don't need
It just turns on.
You got it.
It just turns on. It turns on and off like I cannot.
You just told me. You could have put it there. Where else could you have put it? There. There is kind of the same thing as this. Okay. Where else could you have put it?
You know who else? Wait, come on.
Okay.
Oh yes, let's go.
I
got 5. I'm happy. Mr. Halton.
I mean, like, I did this.
Yeah.
Thing, but that's different, right?
That's your
I just like two methyl.
They said.
Yeah, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the other one.
Can I show you?
Yeah, I guess.
No, Miss Thompson was talking about the grind made during the play yesterday. Everyone turned to me and goes, what does that mean?
Okay, can I? Yeah. I'm just gonna show you this. Can I show you guys all the solutions? They're all line diagrams because that's the easiest one for me to represent. Okay.
Wow.
Wait.
Wow.
Get out of the way.
Wow.
So the easiest ones are probably pent 1-ene and pent 2-ene, right? But then other than that, we could do bute. We could do 2-methyl bute 1-ene. We could do 3-methyl bute 1-ene. We could do 2-methyl bute 2-ene. This is 2,2-dimethyl prop 1-ene or propene, I guess. Cyclopentane, methyl cyclobutane. We could do 1,2-dimethyl cyclopropane, and we could do 1,1-dimethyl cyclopropane. Woo, Jordy.
The X looking one on the top right, doesn't the middle carbon have 5 bonds on it?
Yes,
So is that illegal?
that's illegal. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
There's only 9.
No, because you missed.
I missed
I might have
this
found
one.
that you
Sorry,
didn't, yeah.
I missed.
Well, no, isn't that the bottom right? Oh, no.
No,
that's dimethyl.
this
Yeah,
is
that's
ethyl
the thing,
ethyl cyclopropane. Thank you. There's still 10. So that's. Yeah, I mean you can write them all out or not write them all out. That's totally fine. I wanted to get you. I just wanted to get you to think about isomers a little bit critically. That's all I wanted to get you to do. Okay? Yeah.
I didn't get 2 of those and I got 9. You said it all right. So come here.
Well, maybe I screwed up.
Maybe I should. Yeah, you said these were all different.
This is 2-methyl bute 1.
Why does he have a
This
spare key on?
is 2.
He's like, oh, there
This is 3-methyl bute 1.
I got to talk.
Yeah.
I got it.
One spare key.
Are they the same?
Oh, you have this.
Yeah.
That was mine.
I got to talk. He broke one.
He
Yeah.
broke one of. It's still usable, I think.
Yeah, you can see.
Okay.
Okay, I'm gonna move on from here. That's okay with you.
Take it off.
I want to define some terms here before class ends. So, do you know what the term saturated means?
Yes. So it's
Not an overabundance.
Isn't it like the solvent reach like the maximum solute?
It's like maximum capacity.
Yes.
Saturated means maximum capacity. So if I jumped into a lake right now, this is kind of a weird example, but whatever. If I jumped into a lake right now and then I came out, my clothes would be saturated. What does that mean? Not wet. Not
Not
wet.
wet.
Because if I sprinkle a little bit of water on my pants, are they saturated?
No. It means you can't hold any more.
Yeah, that's right, Sanjana.
Would it mean that like your clothes have reached maximum capacity for holding a certain amount of water?
Yes, so they literally cannot hold any more water, right? Now, what I want to know is this compound saturated with hydrogens? What I mean by that is, could you arrange, without breaking any, without changing the structure, so you still want 5 carbons in a row, but could you fit extra hydrogens on here? If I broke off this double bond, could I add an extra hydrogen here and an extra hydrogen here? You could, right? Does that kind of make sense? Okay. Anything with a double bond means that it is not saturated. What would be the term you would use for not saturated? Unsaturated. And so these are all unsaturated molecules. I want to be very clear. These are saturated. These cyclic compounds over here, they are saturated. Because you cannot force any more hydrogens onto here without splitting the molecule up, without breaking the actual structure of the molecule. Okay? So, yeah, what's wrong with this? You can figure it out. 4 things, okay? Saturated and unsaturated hydrocarbons. Saturated hydrocarbons means they only contain carbon-carbon single bonds. Another way of saying that is all alkanes are saturated. Unsaturated hydrocarbons are alkenes and alkynes. There is the presence of either double or triple bonds. Alkenes and alkynes. And the reason why that is, the reason why we say that this is unsaturated, is because if I drew this, which is what we drew before, is this the maximum amount of hydrogens that these 2 carbons can hold?
Yes.
No.
How many hydrogens are on this molecule right now? 4. And if you broke that double bond, not the whole bond, but if you broke the double bond part of the bond, you could turn this into 6 hydrogens, right? This would be saturated, this is unsaturated. So the presence of double and triple bonds is what makes things unsaturated. That's it. Alright. So draw 3 saturated and 3 unsaturated hydrocarbons. Make sure to draw 1 cyclic compound. Show me your molecules if you want to double check, but otherwise whatever, it's all good.
Floor hockey will be on